Hello and welcome on my session. This will be about my journey, how I created my module, which contains functions related to logging. Forgive me about this exaggeration, that it's one of the best, but you know, this is my baby, so of course, I think that it's one of the best. I spent 9 years with that. Of course, I didn't develop this module every day, but during my different projects, I got different requirements. So I needed to build in those new features into the module. So this is why it took 9 years. It's never was a business project, so it was just a private project that I did. So I try to hand over all my experiences to you during this 45 minutes. First of all, many thanks to our sponsors. Without them, we couldn't have this event. And of course, thank you for attending this session, because without you, it won't be very motivating for me just speaking in an empty room. So thank you for being here. I'm Tibor Sós, a former Microsoft certified trainer and PowerShell MVP. Since 2011, I'm working in different IT engineering roles. All are related to PowerShell development. I'm especially proud of my PowerShell book, online book, that is in Hungarian, so it's a good opportunity to learn Hungarian if you want. You already know PowerShell, so it's just a Hungarian missing. I have this script tools module, which contains the logging functionality that I will talk about today, but it has some other functions related to config file management, property management of objects, and there's a function that enables you to use dynamic parameters for your functions very easily. I also completed a couple of successful large PowerShell projects. One of them was an automation solution to fulfill privileged access management requests. The requests come in the Jira service desk. The script analyzed the request, whether it's compliant with the corporate policies. And if so, then the script also calculated the proper approvers based on the request type, forwarded the request to the approvers, and if the request was approved, then it implemented it in CyberArk. So that was quite a complex project, but it was successful. Outside of work, I play table tennis. Unfortunately, I'm not as good as Jan-Ove Waldner, the great table tennis player of this country, but I try to keep up. You can see my contact details on this slide, and at the bottom you can see my GitHub repo, where you can download my script tools if you want. If you look at the features of my script tools module, you can find some similarities between these functions and the Threads PS framework. Most probably we started to develop our own toolset in parallel without knowing about each other. When I looked at his solution, I realized that this is extremely great, but it's, on the other hand, very complex. So my solution, my design goal was to develop functions which are extremely easy to use. So this is the main difference. I don't have any binaries, just pure PowerShell module, so I think it's much easier. There is a shorter learning curve to use it. First of all, let's discuss what makes logging good, in my opinion. Of course, to set up this criteria also took quite a significant amount of time. So it's not just coding, but defining what makes logging good. First of all, as I mentioned, simplicity of use. There must be only very few functions, very few commands, few mandatory parameters. Most of the parameters should have default values. And the solution should be maintenance-free. This is about logging in the file system. So you must take care about the obsolete log file after a while. But my solution takes care of the purging of obsolete log files as well. The content of log files should be easy to read, and we have the verbose option to show the log entries on the screen that should have nice colors so that you can easily identify the information there. One of the main purposes of logging is troubleshooting, help troubleshooting. So the log entries should contain important information, where the log entry was originated from, based on the source code, line numbers. It should also provide information about the context, from which function, which module the information comes from, and it should also log the parameters that were used during the invocation. What I didn't find very often in other solutions is logging progress. I often develop scripts which cycle through a lot of elements in a collection, and it may take a couple of hours to complete the script execution. So it would be nice to have some sort of indication of progress. Of course, we have the progress bar, but that needs interactive access to the console. If the script runs in the background, you won't see the progress bar. So my solution logs the progress as well as special log entries in the log file, so you will be able to see how your script progresses. Error handling. Here's the gotcha, is that there can be some unexpected errors. You want to do something, but it fails, and generally you don't expect that to have an error. This is especially true for non-terminating errors. The script just outputs an error on the error stream, and if the script runs in the background, no one may notice it. So the logging solution should capture those errors as well and make a log entry from those. One of the recent requirements is to handle multiple log files. Most probably when you create a script, there is a boring part. Do some initialization, setting up connections. Most of the times, those actions will succeed. So there are not really too many value add having those entries preserved on the long run. Of course, it's important to keep those entries if there's an error, but if not, we can forget about those. So the requirement was to separate certain log entries. Let's have a boring one, which can be deleted right away we exit from the script, and we should keep other log files on the long run, primarily for auditing purposes. So we need to have the capability to write log entries into multiple log files. Of course, we need to log objects. We work with objects in PowerShell. We can have the option to log them as list or table, or if there are too many objects, probably it's not efficient to log them in a log file, but we should rather export them in a CSV or any other format. But those files should be maintained similarly to the log files themselves. So we should purge them after a while and so on. And the last feature I implemented is to be multi-platform, meaning that the very same script should run as a traditional script execution in an on-prem server, and the other is to run the very same code as an Azure Runbook. If you have ever used Runbooks, you know that there the log entries, the information type of log entries is just pure output streams. And we also have warning and error streams. The output stream is quite challenging because if those are coming from a function, then those output content can mix up with the real intended return values of the function. So that really make errors. So I will show you how I solved this issue. Okay, I don't really want to waste too much time on slides, so let's switch to demo. Here's a script, quite a common structure of a script. It has a header, information about the author and version number. It has a parameter, and it has a private function called sub function. By the way, can you see the screen? Is it font size? Okay. Okay, so it has a private function, and it has a main body part. First of all, I import my script tools module, and then I set up the logging. Normally, you have a single line of initialize logging, but because with this script I want to demonstrate the different use cases, I initialize the logging in different ways based on this scenario. And then in this script I import an external module as well, and there are some other stuff. So let's start with the demonstration. I do the demo log. Let's pick the first log scenario. This is a basic stuff. We want to have a verbose output. There will be some error and warning inside. So let's see how that looks. Okay, so here's the log displayed on the console as well, but the same content is available in the file. First of all, we have in the first column the timestamp. Second column is the line number. The third one contains the entry type. The fourth one is about the context, where the log entry was injected from. If you see demo log.ps1, that means it's the script scope. And lastly, we have the message of the log entry. If you look at the line number column, you can see a lot of 68 numbers, meaning that all of these entries were generated in line 68 from this specific line here. So the single initialization did the header. It also the header contains quite a lot of valuable information, including the script version that is captured from the help block at the beginning of the script, and some other information as well. It also captures the bound parameters. So the parameters are also logged, and we are still in line 68. Here you can see a couple of removing obsolete file entries, because as I mentioned, if it's self-maintained, meaning that while I'm creating a new log file, that function will look into the same folder with the same log name pattern and purges every log file that is older than 60 days by default. Of course, you can override any default value. 60 days the default. And this is the location here, which is the first log entry that is not part of the initialization. Let's go check what's in line 76. This is it. It's a very simple entry. Basically just single parameter passed the log message. Everything else is calculated by this new log entry function. We can have some indentation if we want to have some sort of detailed information which is not that important. We can apply some indent on it. So this was generated in line 83, and this is it somewhere. Okay, so this is the line. I specify the indent level to be 1. Where I get the line numbers, I don't know if I mentioned the subtitle of this lecture is the beauty of the call stack, because quite a lot of features are backed by the call stack. So I get the line number, script line numbers from the call stack. Here you can see I read the call stack, and it's a collection of call stack objects. I take the first one, the current, that refers to the current scope. And here in the log file, you can see the line number. So this is where I get the line number from. Okay, here you can see also a warning type of entry, error type of entry. There's also a highlight type of entry that was generated while calling the private function of the script. Here I'm calling the private function, and if you take a look at the line number, you can see it's line 11. So this is where this comes from. It's highlighted, and it automatically indented by one tab to the right, because it's in a child scope. So it gives us a structure. Of course, you can override this automatic indentation. Either you can add some more indents from the sub-function. This indent level is a relative number, so it adds up to the indent level coming from the scope. But we have this use absolute indent if you want to override this altogether, and I want to have something aligned to the left. Okay, and we are approaching the end. There's a highlighted entry somewhere in the main script, and there is the line 189, where we have the very last action. It's a special entry type called exit. And even though I have an additional line of code afterwards, this should never execute, because this specific entry type, log entry type, will terminate the script. So we don't need any fancy exiting from the script, because this specific log entry type will do the job. This is especially useful if we are not exiting from the main script, but we want to exit from a function. We will get to that later. Let's see another example. Other scenario, we don't want to have this verbosity, the silent mode. In that case, I don't use the verbose switch for the initialization. So the silent mode, you cannot see the verbose switch here in line 65. But still, I selected one specific log entry to be verbose. This is here in line 83. So you can still select some of the log entries that appear on the screen if you want. The next scenario is how unhandled errors are managed. So here in line 98, I'm trying to remove an item which does not exist. I don't have the error action stop, so it's not a terminating error, but still it's quite nasty to have. Without logging this into the log file, we may not notice this ever. So my logging function, first of all, during initialization, it clears the $error collection. And afterwards, it regularly checks before every log entry is written to the file or to the screen. And if there is anything in the $error, it will just put it in the file and on the screen if we want selected verbose mode. So this is a special error type called unhandled, and we need to be especially careful about those. Generally, we shouldn't have those. I don't like the concept of making every error terminating and add a very huge try-catch covering the whole script, because that's quite annoying if I do step-by-step troubleshooting, and if there's an error, a terminating error in that case, my step-by-step execution jumps to a extremely far location somewhere, and I didn't know where I got there. So I don't really a fan of these huge try-catch blocks. I rather log unhandled errors and fix them, or convert them to be terminating errors and put a local little bit try-catch around it, if this is the solution. Okay, so this was the unhandled error. Let's take a look at what happens if there is a really serious error somewhere in the script. Now I terminated from the script at line 79. So if you look at the source code, here's a special. It's similar to the exit type of entry, but it translates to a sort of an error event. You can see the statistics in the footer that error logs 1. And of course, I could specify an exit code, and we can check it's of course it's there in the last exit code. What else do we have? What I mentioned, it's even more important to be able to terminate from a function. Now you can see that I'm in a line 23 of the source code. So I'm terminating from my sub-function. So some very serious issue happened. There is no reason to continue any execution of the script. I just terminate right from this location. I don't need to pass any special value up to the script level so that it can handle the correct closure of the log file. I can just terminate from this very point, and still the log file will be closed correctly with the footer and so on. Let's see the next one, progress bar. I mentioned that I would like to see progress. This is how it looks like. I actually use the standard progress bar, but after a while, all of a sudden you can see that purple log entry, meaning that it's a progress type of log. If you look at the source code at line 112, it's very simple to give parameters. In this comment row above, you can see the original write progress, how that would look like. It requires quite a lot of parameters, and you need to do the math to provide the percentages, and I hate that. I always divide by 0 and things like that, so I hate it. With my solution, you can see that I only show the write log process what is the collection I'm iterating through. So it can calculate how many elements are there, and it can increase a counter to see how many times this has been executed. And there's an action that I write the progress. And here's an optional parameter, progress log first, when the first purple entry should go into the log file. I set it to 10 seconds. I don't want to waste too much time on that. By default, this is 1 minute. And afterwards, every 5 minutes, an updated progress entry will be written to the log file. So you can track the progress later on, even if the script runs in the background. I mentioned we need to write objects to the log file. Here's an example of a list view. It's quite similar to the format list, but it's more capable, because you can see we have a secret property, and I can mask its value with asterisk characters. We generally don't want to log secret values into log files, so I can mask it. And there is a divider horizontal line so that you can easily separate those objects from each other reading through the log file. And there is a table view that's quite similar to the format table. But these are string format and can be put into the log file. Okay, the next one is when we have many objects to be logged. We generally don't want to pollute a log file with thousands of objects data. Here I just export these to a CSV, nothing special with that. The uniqueness is how I create that log file, that CSV file that is related to line 145. Somewhere here's the piece. This new log file, actually here the log is not specifying the type of file I want to open. Log is the prefix of my functions related to logging. So this is just actually a simple new file function. I specify the name. This is not really the name that will be generated, because you can see here in the log, it automatically inserts the date digits there. So if I run this script every day, these export files won't be overwritten. Of course, you can select to have more digits inserted for the hour, minute, and seconds. And in that case, every execution will have its own separate file if you want. And the same maintenance task is happening behind the scenes. If there were some old export data -numbers.csv files in that folder, it would purge them at the beginning. So it does the maintenance automatically. And let's take a look at the next scenario. I mentioned the alternate log files. So the reasoning is that I want to separate the boring stuff from the important stuff that should be preserved for generally auditing reasons. I don't know if you can see, but now this is the log file. This is the boring stuff. It has now much more digits. It's not just the date, but it's the timestamp as well here. This will be purged right away if I exit from the script, because there were no errors warnings. And here is another one. This is called item-rhythm number. This relates to an item that's being processed by the script, and we want to preserve the content of that, even though there is no error. Okay, so my script is halting at the wait debugger statement, so I let it go. And if I switch back to my file system and I do a refresh, you can see that the boring stuff disappeared, but the item-related stuff is still there. The next one is module logging. Here we require some more explanation. First of all, I have a value variable defined in my script. Here's my variable called $A, and it has some dummy text. It's not important. If you look at this line, I can't really highlight it. So this line that is associated with line 14, if I scroll there, it's here inside my private function. It just logs the content of $A. There is no $A in this function. So this is read from the parent scope, from the script scope. This is quite obvious. Probably most of you are aware of that. So this is fine. But I have this dummy module. Inside the dummy module, I have a get dm info, and it also has a very similar line of code. Log entry from dummy module value of A is A. But here, if you look at the log file down there, you can't see anything related to the content of A. Why? Because unfortunately, the script has its own scope. The module, the PSM file, has its own scope. and those are not in a child-parent relationship. Even though I'm invoking the module function from my script, but the scopes of the module, scopes of the script and the module function are different. So this is why my module function can't display the content of $A. Why I'm sharing this information with you? Because you see that I can manage even multiple log files. So if I change from the boring log to another log file, I need to somehow notify these module functions as well. Please do not put your log entries to the boring stuff, but put it in the new log file. And you can see I don't use any parameters in the new log entry statement that describes which log file should it use. Because I'm lazy. I hate using extra unnecessary parameters. So my trick is the following. Here's what I did. If I want to share something with a module function, I populate that value in PS-bound parameters. This is sort of a hash table. So I create a key called A so that I'll be consistent with the naming of the variable, and I assign the value of A to that key. And if you look at the module function, the second try here, value of A via PS-bound parameters is this. Actually, the PS-bound parameters is always relates to the current scope. So I need to look into the scope of the invocation environment, in this case, in my for my script. This is why I read the call stack again. Thank you, call stack. And in the call stack, I access one level higher scope. And inside that scope, we have an invocation info property, and it has the PS-bound parameters of that scope. So this is how I can actually look into this kind of separated values. But of course, I need to be active. I need to inject that value to these PS-bound parameters. That took me quite a lot of thinking and trials till I figured out this only option. I don't know any better option right now, but this is what proved to be working correctly. And this is what I actually use during initialization of the log file. So if you look at, and if I can find it, where is it? Here it is, in line 117. This is exactly what I do. During initialization of a new log file, I inject the log file name into not this scope, because this is the initialization itself. So I inject this information to its parent scope, and from the parent scope, every other module function will access what log I'm actually using at that time. Or not what log, but what is the latest log that I initialized. And this is the default where the log entries will go. Of course, I can override. So the new log entry has a log name parameter. You can have any log names what you want, but I'm lazy. I don't want to have, so there should be a default option with the most common solution. Okay, so this is how I did the trick. Thank you again, CallStack. And let's move on to see actually how this works. So now this is a module logging with alternate log file. So here we have this alternate log file, And here you can see these get DM info lines. Where is my cursor? So my log function automatically injected these log entries into this log file. I didn't need to specify any fancy parameter to that. Okay, so let's take a look at the next scenario. Runbook. That was a tough one. Let's see how this works. The same script is running. You can't really see any verbosity too much at the moment. You can see a warning and an error. These are native warning and error stream messages. And this can be safely injected to their respective streams because in the runbook, these are captured separately, and these streams won't cause errors in any sub-functions or main functions or anywhere. So these are free to inject right away. But if there are no errors, no warnings, then you would just sit in front of the Azure portal and won't see anything. So this is why I wanted to have at least some of the informational messages converted to be output messages. So here some highlights, and the progress bar was converted to be regular output, and those can be seen on the Azure portal. Currently, my script is waiting at the debug position. So let's see what happens if I let it go. So far, these entries were sort of real time. But if I let it go, and when the script exits, it actually reads the whole content of the log file and converts the whole stuff to be output. So it's causing a little bit of delay when you see, but if you have highlight entries and hopefully warnings and errors not, but highlights and progress type of entries, you will still see some movement on the portal while your script is running. Okay, of course, I can't convert all the progress and highlight entries to output. So you can see that I have only one highlight, even though I have originally a highlight generated from my private function. But that was not converted, because if I converted that to an output message, then it most probably would screw up my main script, because it's not expecting that text to be part of the return value of the function. So again, thanks for the call stack, I can measure the depths of each log entries and only emit those log entries which are at the highest level. So this is what I could do around logging, and basically this is it. It's a miracle because I could finish it on time. During my rehearsals, I've never finished on time, so I don't know what happened. Okay, so we have a couple of minutes for questions if you have. Yeah. Yeah, it's compatible. I tried it. I didn't want to use PowerShell 7 or Visual Studio Code. Any complexity I want to avoid. Yeah. I haven't tried, but theoretically nothing is there which would block it. Unfortunately, I'm not a Linux guy, so I couldn't test it. If someone is volunteering, I would be quite happy to have someone test it on it and get some feedback, because I'm too old. You can look at my t-shirt. So I'm too old to learn very new things. So probably I don't start with Linux at this age. Sorry? You You mean? Yeah, I know, but it's too far from me at the moment, maybe. Yeah, any other questions?
How do you get an overview of all your error messages in all your scripts?
There is no overview. So these messages are written to a separate log file. So there is no concentration or anything about that. There was a question previously whether I can write to event log. I could, but it's not implemented. Actually, it was implemented in the previous version, but it was sort of a patchwork. So I started developing this module 9 years ago without any prior requirements. And gradually, as I had ideas, requirements, I put the features. And after a while, after a couple of years, it was an awful patchwork. So I needed to get rid of it altogether and rewrite it from scratch. And during this rewrite, because there was no requirement from any companies that I worked for to have log entries into the Windows event log, I didn't finish that part, but it's quite easy to add that functionality. Okay? Not yet. I'm not an expert in PowerShell Gallery, so I have that published just a couple of days ago in GitHub, so you can access it. From there, I try to put it on the gallery at some point. So you can access it from under my name if you want. And there was a question.
Have you looked into doing more like structured logging? I mean, where you have structured data elements instead of text?
Well, as I mentioned before, for the other features, I didn't have that kind of requirement. All the companies I worked for, the scenario was that they asked me as a freelancer to give them some solution, but that solution was handed over to sysadmins without any complex development background. And their specific requirement was to have very simple output log files. That's enough. No, it's one thread, nothing. Yeah, so if you need more complex solutions, please use Fred's PS framework. This is the very lightweight version of PS framework, I would say. Okay, if you don't have any, yeah?
One small question that came to mind when you mentioned you used the error log on the error message when exception arises. You just take the message directly that is there, or is it possible when you when it's called with some variable, did you enter the variable, that the content in the variable, into the log? So, for instance, you have a collection with over 100 things, and this in the log it says what the content was that caused the exception.
Well, you can put anything into the message as you want, so there is no blocking for that. You can customize whatever you want to put. There is no automatic solution for that, but you can put anything in there. Okay, thank you very much for your attention. I will have another session about property management on Thursday morning. I have similar easy-to-use solution to search among the property values of objects, comparing objects based on their properties, and updating properties. So you are welcome on that session as well. Thank you very much, guys.